Hi, this is Esteban Sanchez from Galarath again. In previous videos, we have introduced the concept of function points. We've also learned about the different types of elementary processes that we can have in function points. In this video, I'm going to show you how to rate complexity for those elementary processes. Not all inputs can be considered the same, for example. Some inputs are going to be more complex based on the number of fields and based on the number of logical files that are used. Similarly, not all outputs, queries, internal logical files, or external interface files will have the same function point count. The complexity of these elementary processes may vary, and therefore we need to understand the rules that are used to rate complexity for those elementary processes. And that's precisely the topic of this video. Okay, let's start with a quick refresher. These are the 5 types of elementary processes that we can have in function points. External inputs are transactions that bring data into the application. External outputs present information to the users or external systems, and they involve calculations or creation of derived data. External queries present information to the users or external systems as well, but these do not include any calculations. External queries are purely a retrieval and presentation of data. Internal logical files, this is the data that is owned and maintained by the application, while external interface files is data that the application uses as reference only. Once all the elementary processes have been identified, the next step is to rate them based on complexity. Complexity ratings are required because not all the elementary processes are the same. As you can see, these two input forms involve different types and different amounts of input fields. Therefore, one of them is more complex and should be assigned a higher amount of function points. Let's now take a look at how we rate complexity for data files. Complexity for data files is determined by 2 attributes: the number of record element types, or RETs, and the number of data element types, or DETs. Record element types are basically logical subgroups of data within the data file, while data element types are unique data fields within that data file. Let's take a look at an example. This is a database that includes information about instructors and courses taught. As you can see, there are 2 logical subgroups of data: instructors data and courses data. We can therefore identify 2 logical subgroups, or 2 RETs. In addition, there are a total of 11 unique fields of data, so we identify 11 data element types, or DETs. With 2 RETs and 11 DETs, this data file classifies as low complexity. The complexity of a transaction is determined by 2 attributes: the number of file types referenced, or FTRs, and the number of data element types, or DETs. A file type reference is basically a data file that is written or referenced by the transaction. A data element type is a unique data field that crosses the boundary of the application during the execution of the transaction. Let's illustrate this with an example. The expense tracking application allows users to keep track of expenses using an internal file. A new expense can be saved into the system by completing the corresponding input form. When a new expense is saved, the application needs to retrieve the current exchange rates from an external data file. The primary intent of this transaction is to save an expense into the expenses data file. Therefore, this transaction classifies as an external input. One data file is being written and another data file is being referenced, so the transaction has a total of 2 FTRs. In addition, we have a total of 8 unique fields of information crossing the boundary of the application, so we have a total of 8 data element types. With 2 FTRs and 8 DETs, the transaction classifies as an average complexity external input. Once all the elementary processes have been classified based on their complexity, The next and final step is to produce the function point count. To achieve this, we're going to use the function point counting weights. As you can see, each transaction and each data file is assigned a different number of function points based on their complexity. For example, if your application involves a total of 5 average complexity EIs, that accounts to 20 function points. So all you have to do is fill in the blanks. For example, for this particular application, the total number of function points is 90. So this is the end result of your function point counting process. Now, let's see what we can do with this number. The most common use of function points is on effort and cost estimation. A parametric estimation tool such as SEER for software can be used to generate effort, cost, and duration estimates based on your function point count. Benchmarking allows organizations to assess their productivity by comparing against the industry data or their own historical data. Finally, function points can also be used for strategic decision making. For example, make versus buy analysis. An organization can use the function point count to determine if it is more beneficial to develop a specific solution in-house or get a commercial off-the-shelf product instead. And that concludes our presentation today on rating complexity of elementary processes. Please subscribe to the Gallup YouTube channel for more informative videos like this one. This was Esteban Sanchez from Gallup. Thank you very much.